In this question, we're asked when VDD is input to a CMOS transmission gate, the what happens. So we have NMOS FET is on, both FETs are on, neither FET is on, and then the PMOS FET is on, or impossible to determine. There's one thing that we can rule out immediately. Whenever we have something like this, it's impossible to determine because we can always determine something like this. And there is one more thing we need to be careful for. And that is the C, when neither FET is on. Because either one of these FETs, we use both of them at the same time because of the weak logic 1 and weak logic 0. So if we use both of them at the same time, that doesn't mean both are on, both are off, but if we use both in the same thing, we're able to not have to worry about the weak logic. So we're not using C either. Both FETs are on. Well, there is a part in the notes that actually tells about why we should not have both FETs on. If both NMOS and PMOS FETs are on at the same time, the output level is unknown because remember we have to have a specific output level. It depends if we're looking at the PMOS or NMOS. It's going to look something like this. It's in the notes, page 14 about. Lots of current flows, we have shorts, that's not good. So it's not going to be B either. So lastly, we have when our NMOS FET is on or when our PMOS FET is on. Well, we can look at other parts of our notes. You can control F, VDD. We have this part right here. Both NMOS and PMOS are on. We don't want this. We're not looking at this part. Again, that's bad. But what we can look at is this part right here, where PMOS switch pass our VDD correctly. And this is kind of the same section that we had around here. But since it says this, you can assume that the PMOS FET is on if it passes it correctly. When the NMOS FET is passed correctly, it's for 0 volts. So this is for VDD. That's how I looked at this problem.